Have you ever gazed at the night sky and wondered, are we alone? Is Earth the only place where life exists? This question has driven human curiosity for centuries. Today, for the first time, we have the technology to search for answers. Our quest takes us to the far reaches of the solar system, not just for intelligent life, but for any life at all, even the simplest microbe. Discovering life elsewhere would be a revolution, showing that life is not unique to Earth. It would suggest that life could be common throughout the universe. The implications would reshape science, philosophy, and our sense of self. Our search begins by following water, the essential ingredient for life as we know it. On Earth, wherever there's water, there's life, even in the most extreme environments. So we look to the icy moons of the outer solar system, where vast oceans may lie hidden beneath thick shells of ice. These hidden oceans could hold the secret to life beyond Earth. Our ancestors looked to the stars with wonder. Now, we use science and technology to explore the unknown. The quest to find extraterrestrial life is the ultimate expression of our desire to explore and understand the cosmos. The journey begins with a simple question: are we truly alone? When searching for life, we often imagine Earth-like planets. But some of the most promising places are icy moons. Moons like Europa and Enceladus are covered in thick ice, but beneath lies evidence of vast liquid oceans. How can water stay liquid so far from the sun? The answer is tidal heating. Gravity from giant planets like Jupiter and Saturn flexes these moons, generating internal heat. This heat keeps their oceans liquid, possibly for billions of years. The ice shell protects these oceans from space, creating a stable environment. Scientists believe these oceans touch a rocky seafloor, just like Earth's deep oceans. On Earth, hydrothermal vents on the ocean floor support entire ecosystems without sunlight. Similar vents could exist on these moons, providing energy and nutrients for life. Icy moons offer three essentials for life: liquid water, energy, and organic molecules. These worlds are self-contained ecosystems hidden in the darkness of the outer solar system. They may be the best places to search for life beyond Earth. The prospect is too tantalizing to ignore. That's why we must explore them. Our search for life also leads us to asteroids, ancient remnants from the birth of the solar system. These small bodies are time capsules, preserving the original chemistry of our cosmic neighborhood. Some, like Ceres, are rich in water and organic compounds. The Dawn mission revealed bright salt deposits on Ceres, hinting at past or present subsurface brines. Asteroids may have delivered water and organic molecules to early Earth, seeding the ingredients for life. By studying them, we uncover clues about our own origins. Missions like Hayabusa 2 and OSIRIS-REx have brought back samples containing amino acids and complex organics. These findings show that the building blocks of life are common in our solar system. Asteroids are not just rocks, they are storytellers of our cosmic past. They remind us that life's ingredients are widespread, waiting for the right conditions. The story of life may have begun with a delivery from the stars. To explore these distant worlds, we send robotic spacecraft, our eyes and hands in space. Galileo orbited Jupiter and found evidence for Europa's hidden ocean. Cassini flew through plumes erupting from Enceladus, detecting water, salts, and organic molecules. Dawn mapped Ceres, revealing a world shaped by water and geological activity. These missions carried advanced instruments, cameras, spectrometers, magnetometers, and dust analyzers. The data they returned transformed our understanding of these worlds. They confirmed that oceans' energy and organic chemistry exist far from Earth. These robotic explorers paved the way for the next generation of missions. The groundwork is set for even deeper exploration. Inspired by past discoveries, a new era of exploration is underway. NASA's Europa Clipper will perform dozens of close flybys, using radar and cameras to study Europa's ice and ocean. Its instruments will search for signs of habitability and possible plumes. The European Space Agency's JUICE mission will orbit Ganymede and fly by Europa and Callisto, comparing Jupiter's largest icy moons. Future missions may land on these moons, scoop up ice, or even send submersibles into their oceans. Concepts like the Europa lander and ice-melting probes are being developed. These are immense engineering challenges, but the goal is clear: to search for life directly. The next chapter will bring us closer than ever to answering the question of life beyond Earth. The adventure is just beginning. The ultimate discovery may be within reach. What do we hope to find on these distant worlds? Not fossils or footprints, but the ingredients and conditions for life. First, we follow the water. Liquid water is essential for life as we know it. Second, we look for energy sources. On icy moons, tidal heating and hydrothermal vents could power life. Third, we search for the building blocks of life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. KNOPS. Finding complex organic molecules is especially exciting, as it suggests advanced chemistry. Finally, we seek biosignatures, evidence that can only be explained by life. This could be unusual molecules, isotope ratios, or microscopic structures. A definitive biosignature would be the ultimate prize. The search is challenging, but every clue brings us closer. We are learning what makes a world habitable. Each discovery refines our search. The quest is as much about understanding life's possibilities as finding life itself. The answers may change everything. To search for life, our spacecraft carry a sophisticated toolkit. Cameras see in invisible wavelengths, revealing surface composition. Ice-penetrating radar maps subsurface oceans and ice layers. Magnetometers detect hidden oceans by measuring magnetic fields. Spectrometers taste the environment, identifying molecules in plumes or on the surface. Mass spectrometers analyze particles, revealing water, salts, and organics. Future landers may carry microscopes, drills, and mini-labs to search for biosignatures directly. Each instrument is a piece of the puzzle, building a picture of distant worlds. Together, they help us search for life across the solar system. Our exploration has already revealed astonishing discoveries. Europa's disrupted surface and magnetic signature point to a global ocean. Hubble has spotted hints of water plumes erupting from Europa. Cassini's flybys of Enceladus found water, organics, and molecular hydrogen, key ingredients for life. Evidence of hydrothermal activity on Enceladus mirrors environments where life thrives on Earth. Dawn showed that Ceres is geologically active, with briny water reaching the surface. We found that water, organics, and energy are not unique to Earth. Subsurface oceans and the building blocks of life are widespread. We haven't found life yet, but the potential is greater than we ever imagined. The universe is whispering its secrets, and we are listening. We live in a time of discovery, moving from speculation to exploration. Missions like Europa, Clipper, and JUICE will soon reveal the secrets of ocean worlds. They'll answer questions once thought impossible. Is there an ocean? What's in it? Could it support life? The search for life is a journey of self-discovery, teaching us about our own origins and the fragility of Earth. It connects us to the cosmos and to each other. The icy moons of Jupiter and Saturn are no longer just points of light. They are worlds of promise. The universe may be teeming with life's ingredients waiting to be discovered. The journey continues and the cosmos awaits. What will we find? Only exploration will tell. The next great discovery could change everything.